here here this is a circuit. Okay, there are two paths, it's B and A. B is smaller in size and A is bigger in size. What this represents? This represents as plus and this represents as
Positive.
minus. Okay, we can call this thing in the circuit is called battery. Okay,
Battery.
and battery has some potential, so we can call this as what? Potential difference. Okay, so due to this potential difference between plus and minus polarity terminals, you can call them as terminals. NB are what? Terminals.
Okay.
So since there is a difference of voltage between two terminals, there is a flow of charge. Okay, and what was the flow of charge? It was going from positive to negative. So since electron is flowing from positive to negative, the flow of current will be what? Opposite to the
Negative.
flow of
Positive.
electrons. Okay.
Okay.
So what is required for the flow of electrons? What is required? Potential difference. Okay, delta V is called what? Potential difference. When there is a potential difference, the electrons will flow from positive side to negative side, and the current will flow.
Wait, would the electrons flow from negative to positive?
No.
And then the current flows from positive to negative?
If the flow of the current flow will always be opposite to the electrons flow. Okay.
Yeah, so the electrons.
Yesterday I have told you why there is a electrons flow from positive to negative side. How? Suppose you have two terminals, okay, A and B. From the positive from this A terminal, electrons are moving to this side B. That's only there is a positive terminal coming, right? How you can differentiate between them, since you can say this is positive since the electrons are going away from this, and this is negative because electron is coming towards this terminal, right?
Yeah.
Okay, so due to that it is positive and it is negative, so the other way around flow is not possible. Okay, if the electron is coming to that a terminal, it will be negative, it will not be positive. Positive means what? Donated. Okay, you can call it positive means positive terminal means electrons donated. Okay, and negative electrons means electrons accepted. Getting my point?
Yeah. Okay.
So what we need a potential difference to conduct the or to take place the flow of electrons, and then the current. So potential difference is needed between any 2 points, then only the flow of current will be possible. Okay, getting my point? Any doubt in this?
Yeah. No.
Okay, and this is called what? This symbol is called what? Battery
symbol. Okay.
In any circuit, when you see this symbol, this is called battery symbol. Okay, now as we know that electric current is represented by I, so what is the formula of current? Formula of current is I is equal to delta Q over delta T. This is what? This is the charge. Delta Q is what?
The charge over time.
Yes, you can see the change in time.
Okay.
This is I. Okay, and this is represented as what? In ampere. Unit is ampere. AMP we call it, we write it short form, but otherwise it is AMPEI. Okay, this is named after a scientist named Ampere. Okay, so that is the unit of the current is ampere. or you can
Okay.
write it, or you can write A. A is also the unit of current.
Okay.
So for a current flow circuit has to be complete. Okay, here there will not be there will not the current will not take place. Current, if there is a battery, so this circuit is open circuit. Suppose this is, I am writing A and B. This circuit is what? Open circuit, right? Open. But
Yeah.
if I connect something with it, suppose I connect a bulb. Okay, this is a filament. I connect a bulb with it. See, now A and B, the circuit is completed, right?
Yeah.
So if the circuit is complete, then the current will flow. Okay, so
Okay.
remember this line: current will flow only in closed circuit. Done, right? Any doubt in this?
No.
Okay. Second line: current is a flow of charge. Flow of charge opposite to the flow of electrons. Okay. Okay. Remember this line. Okay. It is the flow of charge which is opposite to the flow of electrons. Okay.
Yeah. Okay.
Okay. Now, just to understand the current, okay, I will explain something. Suppose this is wire, and this is wire, and this is a wire, and I have removed some of the part wire, and this is part, this is point A, and this is point B. It is suppose connected with some battery point A and B. Okay, I have connected the points with this battery which is called A and B. Okay, suppose this is a battery, and this wire is connected. Okay, and
Okay.
in the another side there is a bulb connected. Okay, it is a bulb connected. So how the current will take place? Suppose if the or I'm saying, suppose the bulb is not connected, even though if the bulb is not connected, how the current will take place into the wire? Okay, so what happens that, suppose you have what you have, in the wire, since it is a metal, you will have free electrons, right?
Yeah.
You will have so many free electrons in this. They will be roaming in the wire, right? The free
Yeah.
electrons. Okay, so what happens that it's not something like there is one electron and that is flowing all to the in everywhere, and that is giving much the current. No, there is a flow of all electrons. Okay, suppose if you have, suppose there is a pipe. Okay, there is a pipe, and you have a ball. You have so many balls inside. Okay, they are
Okay.
inside the pipe, and if you push this ball, what it will do? It will push another ball, right? With the
Yeah.
same, since their distance between each other, it's a very small. So they will push each other, and this ball will feel the same force that you have applied here, F applied. Okay, and this last ball, if it is A, the last ball B will feel the same force here at this point, right? At this point. Okay, so they are moving all together. Okay, if suppose
Okay.
it is a if you have pushed the ball and they are pushing each other and they are flowing all together. Okay, similar case
Okay.
happens here into the wire. There are so many electrons, there are many thousands of electrons. I have told you the value 6 point Na 6.02 into 10 to power 23. Okay, so this much of electrons are flowing in the wire. Okay, and what happens, there is an electron here. Okay, that 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 comes out of a battery, one terminal, and push this electron. Okay, this pushes another, this pushes another, this pushes another. Okay, so they all go with same collectively. Okay, so that is the current, that is we call current. So current is not just like one electron is moving from one place to another place. It's like so many number of electrons all together going in a direction. Okay, so also wire is what, wire is just a two-dimension quantity, right? Two dimension, either they go ahead or they can go in the another, left or right. There are two directions only possible to go. Okay, so see,
Okay.
there are so many electrons collectively flowing in the wire, either they can move right or left. Okay, so there are two directions possible. Okay, so someone is pushing, if electron is pushing this side, electron are going to this side, and current will be in the opposite direction. Okay, getting my point? This is current. Okay, this is current, not anything, not just one electron. This is about actually so many electrons collectively moving together to give what, that is called current.
Okay, but then current is in the opposite direction.
Yes, it is in the opposite direction of if the electrons are flowing to this direction, current is opposite.
Okay.
Okay.
Yeah.
Okay. And what is the formula we have talked about? Formula is delta Q over delta T. Q is what? Q, the unit
The
of
charge.
Q is coulomb. Yes, that is charge. And it is what? Time is second. So it's coulomb per second or ampere. Okay. If there is a charge difference, so it can be written as Q2 minus Q1 over T2 minus T1. If there is a charge difference over time, then the formula of I can be written as Q2 minus Q1, T2 minus T1. Okay. And
Okay.
what is the condition I have told you? Condition for current to be flowing,
Then
there should be a
there has to be a closed circuit.
closed circuit. There has to be a closed circuit. That is the first condition. Okay, what is the second condition? There has to be a potential difference in potential. Okay, there has to be a difference
Okay.
differential potential. Okay, if potential, that is delta. Okay, so you
Okay.
remember the questions we were doing, that suppose it is a positive charge plus, okay, and it is a
Okay.
minus charge, minus Q charge. Okay, that is minus. If it is Q1 and Q2 we're talking about. So from Q1 and Q2, there are two charges, and if if they will feel what, they will feel some kind of a attraction force. Okay, that is from Q1 to Q2 side. Okay, similarly here, if you have and also the electric, if you talk about electric field lines, they will be away from positive charge and they will be towards the negative charge, right? The field lines.
Yeah.
Okay, similarly, suppose you have VA, a one potential here, and VB, another potential here. Okay, and it is some, there is a potential difference delta V called VA minus VB. That is the potential difference. Okay.
Okay.
So from this place, if you want the flow, okay, so if since this is a potential difference, what is the electric field? Electric field can be written as VA over D, right? The separation between the plates. Okay, the separation between the plates is D. So E can be
Yeah.
written as VA over D, and EB can be written as VB over D, right?
Yes.
Okay. So suppose if I say that EA is greater than what? EA is
Greater than EB.
If electric field is greater than B, that B point, okay, what happens that if it is a positive charge and it is negative, what will happen? The field lines will be what? Will go from positive to this side, right? From
Okay.
positive to negative side, right? That is the direction of field lines. Okay.
Okay.
That is the direction of field lines. So along the field lines, what is happening? If it is a positive and it is a negative, along the field lines, if you see that what is the force? QE. Okay, that is the force along the field of lines. So at every point, what force is occurring? That is what? QE. Okay, so that QE is taking the charge. Suppose this is the charge Q. Okay, if it is positive, then the flow is what is the flow of force? That is to this side. Okay, it means there is a charge flow. But if Q is negative, minus E, what will be the flow of charge? The flow of force will be opposite. Okay.
Yes, it will be positive.
Okay. So since there is a potential difference, so what is we are concluding here? Since there is a potential difference, there is a electric field of lines that are going from one point to another point. Okay, and since there is a electric field lines are flowing along the field of lines, along the tangent of the field of lines, we have a flow of force. Okay, we have a flow of force. So due to that force, one charge is moving from one, because it will have acceleration. Okay, then it has some velocity. So due to that force gradient, we are seeing that the charges are moving from one place to another place. Okay, or we can say, since the charges are moving, there is a flow of current. So did you get this point? How the current is taking place?
Yeah, I got it.
Okay, so from one side you can say, if it is from one side, there is a electric field lines, and along the tangent of the field lines there is a force, that is QE. Okay, that is taking the charges from one point to the another point. Okay, and due to that force, we are getting we can see that the flow of charges taking place. Okay, and due to the flow of charges, there is a flow of current. Getting that?
Yeah, I got it.
So can we from this discussion, can I say that I is proportional to V?
Yeah.
If there is a potential difference, then I can take place. Okay, then current flow can take place, right? So from this conclusion, can I say I is proportional to V?
Yeah.
Okay, so if I is proportional to V, so there has to be some constant as well. Okay, there has to be some constant. So I is proportional to V, and then I can say V is equal to IR. Okay, or this could be say that V is proportional to I, right?
Yeah.
Okay, so since there is a proportionality, we'll have to take some proportionality constant, right? So there are V is equal to IR. Okay, R is what?
That's the resistance.
Okay, and this law is called Ohm's law. Okay, so Ohm's law basically is telling about the dependency of voltage on current. Okay, so it is called Ohm's law. Okay, V is equal to IR. Okay, or we can write I is equal to V by R. Okay, this
Okay.
Ohm's law dependency is derived after the experimentation. Okay, this the first experiment was done, then they found that I is proportional to V, but there is some constant as well. Okay, that was resistance. Okay, so when they start experimenting with different type of resistance, okay, different values of resistance, it was coming with a this relationship. Okay, it was following this relationship. Okay, so they have called this Ohm's law. Okay, and if you make the
Okay.
diagram of Ohm's law, that will be what? I proportional to V. If it is I and V, okay, then it will be what? It will be a straight line. Okay, since I by V is what? I by V is 1 by R. It is
Okay.
I by V is 1 by R. Or you can write it, if you not like this, if you write and V and I, okay, then it will be what? V is equal to IR, right? V is equal to IR. Okay, okay.
Yeah.
So
Okay.
this is the graph of Ohm's law. Okay, okay, and this Ohm's law can only be followed by what? Metals. Okay, it's not in every case it's not possible. Only with the metals it's possible. Okay, this Ohm's law can be followed by the metals only.